All right, we're back. We're on page 49 of math analysis, and we're going to be graphing tangent. And remember, the thing to avoid is screwing up the period of a tangent graph. So you get really into the zone with sine, cosine, secant, cosecant, 2 pi over b, 2 pi over b. But tangent, the natural period is pi, so we're going to do pi divided by b. Virtually everything else is identical. So we're going to start here with pi divided by 3/4, which will be 4 pi over 3, which is sort of convenient because the increment is 1/4 of that, so the increment's just going to be pi over 3. Now our start, remember what you can do, take everything in parentheses, set it equal to 0, and solve. So what I do is I just focus on this. I'm going to multiply by 4. So that's going to give me 12 pi over 5. Then I'm going to divide by 3, which gives me 4 pi over 5. So I'm getting 4 pi over 5 as my starting point. So they do not have a common denominator. So I'm going to get a common denominator between my increment and my start. So that's going to be 15s, I guess. So 5 pi over 15 and 12 pi over 15. So there is no sinusoidal axis because it's not a sinusoid, but the same basic idea holds true, especially, I mean, if you think about it, it's sine over cosine. Like there's a lot of sinusoids involved. So the middle point, which is kind of equivalent to the sinusoidal axis, is the same as the sinusoidal axis for sine and cosine. So in this case, it's just y equals -10. And then our high point, we're at our middle point, we can go up what would be the amplitude, but it doesn't have an amplitude because there's no maximum distance that you can get from the sinusoidal axis, but the idea is the same. So we can go up 5. So that'll take us to y equals -5. We could go down 5 as well, which takes us to -15. And then we don't do the domain range. Well, the range is all real, so we could actually just do that right now. So y is an element of the reals. Domain and asymptotes we'll save. So let's see if we can do this. So I need to go -15, -5 to -15. So I'm going to try, I'm actually, so when you're graphing tangent, you want to the smaller you can make the range, the better, sort of. So I'm going to go with 0 here, and let's say -5, -10, -15. And then what can I do? I've got 1, 2, 3-ish above and 1, 2, 3-ish below. So that's looking really good. I'm going to put in my x-axis. And I guess I'll move that up because that missed by a lot. Okay, we got that. In the middle of this, I'm going to put the start, which is 12/15. So in the middle, wherever that is, here, let's say 12/15, 12 pi over 15, really. And then my increment, so you want to go 1 box per increment, but labeling all of those is insanity. So what I'm going to do is I'm going to label every other, but I'm going 1 box per increment. So I'll do tick marks on every other and then label every other. So it's like this would be 17, and then this would be 22, and then whatever, and then 32. So I'm skipping. So we're going to get a lot of periods of the graph here because if you go 2 boxes per, it just gets way too stretched out. So we're going to end up with a lot of periods of this thing, but that's okay. Then we want to go the other way. So there, and then this will be 2. And I got to subtract 10. So it'll be -8. And you just hope you got that right. -18, -28, and -38. So I mean, to do it right, it takes a while. So I mean, these videos, they run a little long, but I mean, you know, if you're going to talk your way through it, it's going to take you this long. Like there's basically nothing you can do about that. So you don't have to dot in a sinusoidal axis because it doesn't really have one, but it can help your graph look a little more complete, and it can certainly help you while you're doing it. So I'm going to actually dot in an axis going across here at -10. So just dot it. It doesn't have a sinusoidal axis, but your graph will look better if you're careful about where things go. And since a dotted line isn't a part of your graph anyway, I'm gonna put it in. You know what I could have done is I could have put a solid line in, and then at the end I could have erased it. That's like movie magic though, and you don't really have that option on paper, so I'm not gonna do it. But I could do it, and I think it would look cool. All right, so this is a normal tangent. So starting at the starting point, we're gonna go middle point, high point, asymptote, low, middle, and then just continue the pattern. So let's see if we can do that. So the middle points are at -10. So that's gonna be right here. So I'm gonna highlight the starting point just so that it's easier to find. You don't really do that. And then we're gonna go 1 box per increment. So it's middle, high, and then an asymptote. And let's see, can I do like, I kind of want to make like an asymptote that I can just paste. This isn't gonna really work, but I'm gonna try. So I just want to copy, oh man. Let's see if I get this. So I want to, well, I'm gonna want to duplicate this. And then maybe I'll just like keep doing them, right? So let me duplicate this, and then it's gonna go low, middle, high, another asymptote. I'm gonna duplicate this. It's gonna go low, middle, high, another asymptote. And then let me duplicate this and go back. So it's high, middle, low, another asymptote. And then duplicate, high, middle, low, another asymptote. Duplicate, high, middle, low, another asymptote. So did I kind of cheat? A little bit. I mean, it's not going to really change the way anything ends up looking, but at the starting point, we went middle, high, asymptote. Now it's going to be low, middle, high, asymptote, low, middle, high, asymptote, low. Going backwards, so it's, you know, we're high, middle, then low, asymptote, high, middle, low, asymptote, high, middle, low, asymptote, and then high. All right, so now we gotta put our curve in. Do not get obsessed with getting to the asymptotes too quickly. That's the #1 mistake that people make on graphing. With finding the information, it's finding the period. But after that, it's definitely a lot of mistakes I see trying to like squeeze this graph in here. So let's see. So you just kind of like go for it. That's a pretty good one. I do not anticipate them all looking like that. Not bad though. I'm not sure why this is going so well for me. You know, part of it is that I made the range really tight. The tighter the range is, the easier it is to make these. So I definitely recommend that you like take advantage of that and do a little bit of planning ahead of time. I lost that one. It's like my hand stuck to the iPad, basically. There, these are coming out all right. Now I'll probably like check it and find out I got everything wrong, and that'll be sad. All right. So what do we think that the asymptotes are? So I see one at let's say I'm going to use this one. And then how far apart are they? They're 20 pi over 15 apart, which should be 1 full period. And it is 1 full period, and that's awesome. So you can see up here the period is 4 pi over 3, but multiplied by 5 over 5, you get 20 pi over 15. Perfect, because they should be 1 full period apart. So let's say our asymptotes are x equals 2 pi over 15 plus 20 pi over 15 times n, where n is an element of, what am I drawing? Of the, I think I was going to say the reals of the integer. Oh, you didn't even see that because my face was in the way. Yes. Now the domain is everything except that. So x is an element of the reals. X is not 2 pi over 15 plus 20 pi over 15n. So you can simplify the fraction. I think that people simplify like more often than they should. I think a lot of the time when you don't simplify, you like see the structure more clearly of what's going on in these sorts of problems. But you know, it's up to you. I mean, you can, you know, do whatever you want. I'm going to check this on the calculator by like plotting, by checking points basically. So I'm going to define the function 5 tan of 3x over 4 minus 3 pi over 5 minus 10. Okay, so I'm thinking that f of 12 pi over 15 should be negative 10, and it is. I think that f of 17 pi over 15 should be negative 5, and it is. I think that the domain of f of x should be all reals. So the calculator never says all reals, which is kind of annoying. So it's all reals except 2 pi over 15 plus 4 pi over 3 times n. Let's see what it says. All right, let's try to expand that. And then let's add 4. I don't know why. It always seems to choose like the first negative, which is kind of weird to me. So here I get 2 pi over 15 plus 4 pi over 3n. Yes. Okay, so those are basically the asymptotes. So that worked out. So let's go back. Definitely not going to try to do another graph in this video. That's too long. But this went really well, I think, and we got a pretty good graph out of it. So I'm going to cut it here and come back in the next one and do the rest of the page. So I will see you there.